Well, hey everybody, Mr. Reeves back with you, and today we're looking at lesson 18.4 in the Accelerated Math 7 book, equations with many solutions or equations with no solutions. So we've been solving equations for a while now, one-step equations, two-step equations, multi-step equations, equations with rationals. But did you ever stop and think that an equation might not have a solution? Or perhaps an equation is always true. Remember, what I've told you is solving an equation is finding the value of the variable that makes the equation true. Again, solving an equation is finding the value of the variable that makes the equation true. So let's look at one first, like what we're used to seeing. All right, so we've got this equation right here, 4x minus 3 equals 2x plus 13. So we got an equation with variables on both sides. Now, if I were doing this problem, the first thing that I would have done was subtract 2x from both sides. All right, but they chose not to do that. They chose to add 3 to both sides, which is perfectly fine, right? And then they got 4x equals 2x minus 16, right? Then they subtracted the variable term with the smaller coefficient from both sides. They got 2x equals 16, and then they got x equals 8. So again, what did they find? They found the value of the variable that makes the equation true. If I go back up to my original equation and I go 4 times and I replace x with what our solution came out to be, it should make both sides of the equation equal. That's what a true equation is, when the left side is equal to the right side. Well, 4 times 8 is 32, and 32 minus 3 is 29. It works. 2 times 8 is 16, and 16 plus 13 is 29. So 29 equals 29, which is, again, a true equation. So we found the value of the variable that made the equation true. And that's the only thing that will ever make it true. If I put any number other than 8 in for x, the left side and the right side will not be equal. So again, that's what we're used to having happen. But let's take a look at a different type of problem right here. So this one, we've got 4x minus 5 equals 2 times 2x minus 1 minus 3. So this is going to be a multi-step equation where we're going to have to apply the distributive property, right? Because this right-hand side, this expression, is going to have to be simplified. So here we go. We're going to apply the distributive property. 2 times 2x is 4x. 2 times minus 1 is minus 2. And then we're going to combine like terms, all right? So we get 4x minus 5 equals 4x minus 5. Now let's just stop right there and look at what that says. What is the left-hand side? 4x minus 5. Whoops, one line up too many. What is the left-hand side? 4x minus 5. What is the right hand? Whoop, what just happened? Didn't mean for that to happen. Can I hide that? No, wrong direction, Mr. Reeves. All right, here we go. 4x minus 5. 4x minus 5. Right there, we now have an equation where the left side and the right side are equal. Now think about it. What are we trying to do? We're trying to find the value of the variable that makes the left side and the right side the same. But they're the same. So what could I put in for x that would make 4x minus 5 equal 4x minus 5? I could put in anything. Now, they didn't stop there, although you certainly could have stopped there. They subtracted 4x from each side, and they got negative 5 is equal to negative 5. All right? Now, sometimes my students will tell me that x is equal to negative 5. They get negative 5 equals negative 5, and they turn it into x equals negative 5. Now, certainly, negative 5 will work. If I put 4 times negative 5, whoops, excuse me, let me try this again. If I do 4 times negative 5 minus 5, then I get negative 20 minus 5, and that, of course, is equal to negative 25. So the left-hand side equals negative 25 when I put negative 5 in. If I do the right-hand side, I get 2 times negative 5 minus 1 minus 3. Well, let's do what's inside the parentheses according to order of operations. I get negative 10 minus 1. That's negative 11. So 2 times negative 11 minus 3. Well, 2 times negative 11 is going to be negative 22, right? All right, and they're equal, and the student got negative 5, and they check their answer, and they're going to think everything's great, right? But let's try something else. Let's try 0, because 0 is a great, easy number to do math with. 4 times 0 minus 5 equals 2 times 2 times 0 minus 1 minus 3. Well, 4 times 0 is 0, right? 0 minus 5 is negative 5. 2 times 0 is 0. Minus 1 is negative 1. So this becomes 2 times negative 1 minus 3. Well, that is also negative 5, negative 5. Well, wait a second. X equal negative 5 worked. X equals 0 also worked. So what does that mean? Well, maybe it just has two solutions. Well, as you know, I can try anything I want to. Everything is going to work. And the reason everything is going to work is because when you simplify this right side of the equation, you get the exact same expression as on the left. All right? So think about what we're trying to do. We're trying to find the value of the variable that makes the equation true. We're trying to find the value of the variable that makes 4x minus 5 equal 4x minus 5. And that's everything. So there are infinitely many solutions. Or sometimes we say x equals any real number. Okay, so that is a special case right there when the left side always equals the right side. How will you recognize that? Because you will get to a point somewhere along the line where the left side and the right side are exactly the same. I usually just stop. The minute I see they're equal, I just stop. But you can take it all the way until you have a constant equal a constant. Or if they had added 5 to both sides, right? Instead, they would have had 4x equals 4x, right? Or if they divided then by 4, you get x equals x. All right, just look for the left side equaling the right side, and that means there are infinitely many solutions. X can be anything. All right, so what about this last case here? All right, and I don't really like their last case because the way they wrote it, so let me do my own example here. All right, 4 times x plus 2 equals 4x plus 2. All right, I want to solve this for x. I want to know what value of x will make this left side equal the right side. Well, I'm going to go ahead and apply the distributive property here, and I get 4x plus 8 equals 4x plus 2. All right, now, Mr. Reeves said when you have variables on both sides, find the one with the smaller coefficient and subtract it. Well, they're the same. So I guess I'll just subtract 4x from each side since I don't have a choice. And what do I get? I get 8 equals 2. What does that mean? 8 equals 2. Does that mean x equals 8? Does that mean x equals 2? Well, if I go back to my original equation, if I try 8, 4 times 8 plus 2 equals 4 times 8 plus 2. Well, this would be 4 times 10, which is 40. This would be 32 plus 2, which is 34. Well, they're not that far off, but they are not equal. So x doesn't equal 8. Well, maybe x equals 2. 4 times 2 plus 2 equals 4 times 2 plus 2. Well, let's see. That's 4 times 4, which is 16. And that's what 8 plus 2, that's 10. Well, those aren't equal either. Well, 8 didn't work. 2 didn't work. What's going on here? All right, stop and think about what's going on. Let's take a look right here where we have 4x plus 8 equals 4x plus 2. Well, think about it. No matter what we put in for x, 4x will always equal 4x. 4x equals 4x always. All right? Those two will always be equal. All right? So that leaves 8 equals 2. Well, when was 8 equal 2? Well, that one is what? Never. All right. So if we take away the part that is always equal, we're left with something that is never equal. So this is never true. So this one has no solution, right? Just think about it. When does multiplying by a number and adding 8 give you the same result as multiplying by that same number and adding 2? Never. This will only be true when 8 is equal to 2 and 8 never equals true. So this is their example, very similar. It just was more similar right off the bat. You could just look at it. 4x will always equal 4x. When will 2 equal negative 5? Never. All right, so you can know that it's no solution. You notice at the end here you get a false statement. 0 does not equal negative 7. They will never equal. There's no solution. Here we got a true statement. So they have this nice little table here that they give you. All right. So when you're solving an equation, if you get x equals or y equals or k, whatever variable equals, if on one side you get to the variable and on the other side you get to a constant, that means you have one solution. If somewhere in the process of solving you get the left-hand side and the right-hand side looking exactly the same, whether it's a constant equals a constant, a variable equals a variable, or an expression equals the exact same expression, then it has infinitely many solutions. And whatever your variable is you're trying to solve for, it can be any real number. All right? And conversely, if you're going through that same process and you get to the point where you solve it and you get a false statement like 4 equals 2 or 0 equals 7, all right? Or if the variables are the same but the constants are different like we saw, then that has no solution. There's no way to make those equivalent, all right? So that is how you can recognize those problems. All right. They also in this lesson wanted you to create some equations that had no solutions or had infinitely many solutions. So what you do is you just work backwards. So if you're trying to create an equation that has no solution, start with a false statement. All right. Start with a false statement like 3 equals 5. And then whatever you do the same thing to both sides and just build up from there. So you notice, what did they do? They started with 3 equals 5, which of course is a false statement. Then they added the same thing to both sides. All right. 3 plus x equals 5 plus x. Then later on they added 7, right? They went there and they added 7. So remember, if you do the same thing to both sides of an equation, you don't change the solution of an equation. So if you start off with a false equation and then you build up around it by doing the exact same thing to both sides, no matter what equation you create, it will always stay false, which means it will always have no solution. And of course, if you wanted to create an equation with infinitely many solutions, instead of starting off with 3 equals 5, start off with 5 equals 5, right? That's a true equation. That is always true. So again, if we added x to both sides, what would we have? We'd have x plus 5 equals x plus 5, which of course is still a true equation. And then we could do whatever we wanted to both sides. It would always stay true. It would always have infinitely many solutions. Okay, so that's an introduction to this lesson on equations that have infinitely many solutions or no solutions, or most of the ones you're going to encounter are going to have that one solution. All right, in our next video, we'll just go through and do a whole bunch more examples. All right, until next time.